Let's look more specifically at some of the things. How do we get there? So we said mitigation is important and, oops, okay. Mitigation is important and it has co-benefits, it's worth the investment and so on. So what are the options? And we said if we choose a future target and look at the emission pathways we are on, you can say with some confidence how quickly we will get there in terms of the total CO2 that we can afford to emit into the atmosphere. Lots of uncertainties in those carbon calculations, and as I said, not everybody agrees, especially social scientists tend to think setting deadlines is not a good idea. So here is more science pathways of doing this. If we look at the warming and the pathway we have already been on from 1950 onwards, right? And those are the projections. If you mitigate nothing, so if you just keep emitting as we are, then business as usual, as it is called, will quickly bring us to 4 degrees and more by 2100, and by 2050 we would be pretty close to 2.5 degrees and beyond. And there are detailed calculations by the IPCC about what would happen with the global warming of 2.5 degrees in terms of species extinctions, crop yield losses, forest losses, sea level rise, human health, and so on. These are based on several past experiences and the best knowledge we have, with uncertainties, but it's pretty clear that beyond 2 degrees it does become problematic. This number 2 degrees is argued a lot about as well. This was probably first introduced by Nordhaus, who won the Nobel Prize for his climate economics work, and he used it in the 1970s. It's a nice round number. Then the Stern report in the 1980s used it, and IPCC is now using it, but it's not a scientific or geophysical number. It's a choice that is somewhat justified post-facto, but that's a debate for another time. Okay, so let's assume that's a dangerous threshold we don't want to cross. So then if you just mitigate CO2, you will bend the curve. This is the idea of bending the curve. Here is business as usual. You're bending the curve with CO2 only mitigation down to about 3 degrees from more than 4 degrees. This is already in dangerous level. This is still in dangerous level. If you then also begin to mitigate the short-lived climate pollutants that we talked about, we will see again, you will delay the warming. So this warming is much more rapid. You can see here. This will delay the warming, but eventually you will get to the same place. But the delay is critical in terms of its beneficial impacts on human health, productivity, crop losses, sea level rise, and so on. Okay, but nonetheless, by 2100 you might end up at the same place. But good news is, if you do immediate mitigation of CO2 and short-lived climate pollutants, then you will come into this safer zone of less than 2 degrees centigrade by 2100. Again, there's a probability here. This will be something like 66%, I think. Nonetheless, you have more than an equal chance of avoiding the catastrophic consequences of global warming, not only on ourselves, but also on all the species that we talked about. This is the main message. How do we get there? The emissions, actual or projected warming, and committed warming under a business as usual scenario where we just continue to live our energy intensive lifestyles without worrying about renewables, efficient and electric vehicles, and food wastage, reduction of emission from deforestation, forest degradation, and so on. We were emitting a cumulative CO2 of 2.2 trillion tons since Industrial Revolution by 2017. Actual or projected warming associated with that, if we just cut off somehow magically all emissions at that level would be 1 degree C, but we would be committed to a warming of 1.5 degrees C. What does that mean? Essentially, the CO2 that is in the air slowly decays away. As we said, its residence time is centuries to even millennia. So as long as it's there, it's trapping more energy. So even though the warming will slow down, the warming will continue for a long time, multiple centuries, and will eventually reach in equilibrium 1.5 degrees. That's called committed warming. We are on a transient warming rate that's not keeping up with the sensitivity of the climate compared to, let's say, what has happened with the ice ages and deglacial periods. So remembering that the CO2 lifetime or residence time is very long, even if we stop emitting everything, what's already in the atmosphere, 2.2 trillion tons, will continue the warming, which we call committed warming. That does not mean there is no point reducing emissions, because as you can see here, if we increase the emissions to 3 trillion tons, then our committed warming goes up to 2 degrees, and 4 trillion gives us 3 degrees. So we must cut carbon dioxide, carbon emissions. Each additional gigaton is going to give us each additional committed warming. So it's just that committed warming cannot be avoided, because unintentionally, without knowing the consequences, we have already put in a bunch of carbon into the atmosphere. Okay? That's the main message. I will talk about the 6 clusters in the next podcast, because this already went to 6 minutes, 7 minutes, and I wanted to kind of leave those ideas with you. Reducing just CO2 or CO2 plus SLCP or business as usual give us a clear sense of what we mean by bending the curve and why we are trying to do the bending of the curve and how we will do it. We mentioned 10 solutions. We will look at it, and they fit into 6 clusters, 6 pathways, if you will, on how we would implement those solutions, how we would innovate, evolve, and get the ability to implement those solutions. Not easy, but we can do it. That's the main message.